Good morning everyone, this is BremSter and today I'm coming to you with 13191319 by Riffclown. This is a new Riffclown puzzle. There hasn't been one of these for a while, so I'm really looking forward to it. This is a duality puzzle, which Riffclown has been working on a bunch of duality puzzles. Some of you may know why recently, and this one is one that Riffclown submitted. He released it on Logic Masters Germany, and I'm interested in Riffclown puzzles. Riffclown is probably my favorite setter. There are other setters I really enjoy. You know which ones they are, but when I get a Riffclown puzzle, it's always an exciting thing. So I'm looking forward to this one. We are coming up to the end. We may be at the end when this comes out of Quads on Parade. So I hope everyone's enjoyed those puzzles. There's definitely been a change in the responses as the puzzles have got harder and harder. So that's been interesting to watch. There's more stuff along the lines of packs coming, so we'll see how that all goes. Let's just get straight into the puzzle. Too much preamble is just wasting everyone's time, so let's get into it. So we have normal Sudoku rules apply. So in every box, in every row, and in every column, the digits 1 to 9 must be placed without repetition. Duality. External clues are both normal X sum and little killer clues in both directions. So little killer. Clues outside the grid with an arrow are the sum of the digits in the cells along the indicated diagonal. Digits may repeat along these diagonals if allowed by other rules. So for example, the 13 is pointing in this direction, those cells sum to 13. The 19 is pointing in this direction, those cells must sum to 19. X sums. A number outside the grid gives the sum of the first n digits in that row or column, where n is the digit in the cell closest to the given clue. So in this row, for example, if this was a 3, then these 3 cells would have to sum to 13. If this was a 4, then those 4 cells would have to sum to 13. That's the way X sums work. So these clues, these numbers are serving, in these cases, triple purposes, because this 13 is a little killer here, a little killer here, and an X sum here. Interesting. I'm going to restart the puzzle to restart my timer. Let's give this a shot. So I normally like to start with X sum to say, what could this clue be? It can't be a 1. Because if it was a 1, it would be summing the 1 cell, which would be a 1, and this clue would be a 1. If this was a 2, I'd be summing these 2 cells, but this would be a 2, and to get to 13, this would have to be an 11. That doesn't work. It could be a 3 if these sum to 10. I think it could be a 4, because I'd need those 3 cells there to sum to 9. And I could do that, because I could go like 4, 1, 2, 6. It can't be a 5, because the minimum that 5 cells could sum to is 1, 2, 3, 4, 5, which is 15, which is higher than 13. So this is 3 or 4, this is 3 or 4. This, now again, it can't be 1, it can't be 2, because if, oh no, it might be able to, no, it can't be 2, because if this is 2, this would have to be a, if this was 2, this would have to be a 17. It could be 3 if this was an 8, 9. 3, 8, 9 would mean that 3 plus 8, 9, no, if this is 3, these would have to sum to 16, which would be 7, 9, but it could still work. It could be 4, because 4 would mean these 3 cells would have to sum to 15, which would mean that they'd include a 5. So if there's a 4 here, there's a 5 in one of those two. And that's just using entropy because no 6 is available. If this was a 5, that would work as well, because I can make 5 cells sum to 19. I can't make 6 cells sum to 19, because the minimum would be 1, 2, 3, 4, 5, 6, which is 21. So this is a 3, a 4, or a 5. That's not where to start. 2 cells summing to 13, 9, 4, 8, 5, or 7, 6. These 2 cells sum to 9 without being 4, 5. Ooh, those 6 cells sum to 13. Now that's restricted, because the minimum that one set can sum to is 6. Right, so the minimum would be 1, 2, 3, 1, 2, 3, which would sum to 12. So what I can do is I can increase one of those digits in the entire run by 1. So it has to be a 6 in one run and a 7 in the other. So because if I make one of these a 1, 2, 3, I can make another one a 1, 2, 4, because the only way I could put 7 in the other run would be 1, 2, 4, because in order to increase a 1, 2, 3 to a 7, I can't increase the 1 without making a duplication in the box, and I can't increase the 2 without a duplication in the box. So I could make it 1, 2, 4, and then I can't increase the other one at all. So one of these has to be a 1, 2, 3, the other one has to be a 1, 2, 4. There's no other way of increasing it. And I can't put a 1 or a 2 here. So this is a 1 or a 2, and this is a 3 or a 4. And I can't put a 1, 2 here. This is a 1 or... So this 1, 2 is doing a lot of work. And this is a 3 or a 4. One of these is a 3, one of those is a 4. And they're different. So I can get rid of those colours. But I do know these are different. So I'm actually going to colour those to indicate that they are different. Does that mess with this 13? Let's use a line instead. Does that mess with this 13? Because the minimum here now is 3, 5. Because I can't do 3, 4. Because I can't use 1, 2, and I can't make these 3, 4 because that would break this cell. So the minimum here is 3, 5, which is 8. And the minimum here is 2. So the minimum I've got here is 10. 3, 5 here is the absolute minimum. Can't use 1, 2. Can't use 3, 4. The minimum here is 3, 5. The minimum here is 2. So the maximum, this has to be a 1, 2. The 1 here makes this the 2 and this the 1. That looks across making this the 1 and this the 2. This has to be a 2 because... Yeah, because the minimum these can be is 10. So this is the 2. This is a 3, 5. This is a 4. So this is a 3. The 2 makes that the 1 and that the 2. Okay, and I can get rid of that line and all the colouring. Okay. There's no 4 here anymore. That's a 3, 5 pair. So if this was a 5, how would I make this work? Because if this is a 5, these would need to sum to 14. But the minimum they could be would be 1, 2. I couldn't use 3, 4, 5, 6. 1, 2, 7, 8. And if they were 1, 2, 7, 8... Well, 7, 8 is 15. So this is a 3, and this is a 5, and this is a 3. And these have to sum to 16. So there's 7, 9, because I can't do 8, 8. These are 1, 2, 3, 4, 5, 6, 1, 2, 8. There's no 1 in either of those. That's the 1, that's the 8, that's the 2. Okay. So what? If this is a 4 now, those would have to sum. If this was a 4, those would have to sum to 9 without a 1 or a 2, which doesn't work. Because a 9 in 3 either has to be include a 1 or be 2, 3, 4. That's a 3. These have to sum to 10 without using a 1, a 2, or a 3. So they can't be 1, 9. They can't be 2, 8. They can't be 3, 7. This has to be 4, 6. And the 4 makes that the 6 and that the 4. Five is in one of those two. So 5 is in one of those two. 1 is in one of those two. 1 is in one of those two. But if this is a 1, that's a 9. No, if this is a 1, that's an 8. Oh, is it this 19? I haven't looked at these 19 clues yet. Oh, this is a 1 in the corner. This 13 still seems to have options. So if this is 3, these sum to 10. They couldn't be 1, 9. They could be 2, 8 with 8, 2. They could be 7, 3. Oh no, if this is 3, they couldn't be 7, 3. But they could be 4, 6. If this is 4, those would have to sum to 9. This would have, and that doesn't work. This can't be a 4. If this is a 4, these would need to sum to 9. Now, if I don't use a 1, it'd have to be 2, 3, 4. But I've used a 4 here. So this can't sum, and I can't use a 1 because this one prevents it being a 1 here and this one prevents it being a 1 here. This is a 3. These must sum to 10. I can't use 1, 9. I can't use 3, 7. If it's 2, 8, it's 2, 8. And if it's 4, 6, I don't see an order problem. Okay. So, is it this 19 now? This is a 3 by Sudoku. That's a 3. So I've got 6 on this 19 line. So these need to sum to 13. So this can't be a 1. If this is a 1, I'd only have 7 on this line. And this would need to be a 12. That's not the 1. That's the 1. That's not the 1. That's the 1. So what can this be? It can't be 1, 2, 3. It could be 4. It can't be 5. It could be 6. It can't be 7. It could be 8. It can't be 9. So this is 4, 6, or 8. So if this is, and these have to sum. Well, these are 6. These have to sum to 13. So it's 4, 9, 6, 7, or 8, 5. And I'm not seeing a problem with any of that. This is a 3 by Sudoku because 3, 3, 3. 3, 3. So, 3... Oh, I've got 3 in this box. What's this triple? 7, 8, 9. Okay, that didn't help. 4 is in one of those two. This is a 4, 6 pair. So 1, 2, 3, 4, 5, 6. These are 7 and 9. So these, 1, 2, 3, 4, 5, 8. But hang on, these sum to... Does this interrupt this? Because these sum to 13. If this is 9, 4, this is 8, 2. If this is 8, 5, this is 4, 6. If this is 7, 6, this is 8, 2. I can see 2 is in one of those. This is a 5, 8 pair. Because 8 can't go in any of those. So 1, 2, 3, 4, 5. These are 7 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. These are 4 and 6. So 1, 2, 3, 4, 5, 6. These are 7 and 9. So I'm getting down to pairs. That's 7, 8, 9. Does that, well, 8 is in one of those two. So there's no 8 there. That gives me a 7, 9 pair. So this is 4, 6, or 8. 3 is in one of those two. Is it this 19? So these are restricted. This can't be a 2, can it? If these are 2, these sum to 15. No, that does work. 8, 7, 6, 9. No, that works. Unless it's interacting with this somehow. Because these are from 2, 4, 5, and 6. Yeah, 8 is in one of those. So these are from 2, 4, 5, 6. There's no 4 there. So this is only from 2, 4, 5, 6. Okay, what am I missing? Is there some relationship between all of this that I'm not getting? These summed to 13. 4, 9, 9. So if that's a 4, that's a 9, that's a 9, that's a 7. If that's a 6, that's a 7. That's a 9, that's a 7. That's an 8, that's a 5. Oh, there's no 4 there. Uh, these sum to 10. If this is 4, 6, how? Three is in one of those two. Five, 6, no. I feel it's got to be this little killer thing. The only X sum I haven't resolved fully is this one, because this is down to the 3, 7, 9. 9, 4 would be 9, 4. 8, 5 seems to be able to go in any order, as does 7, 6. 2 is down here. If this was a 2, these would have to sum. If this is a 2, these sum to 15. If this is a 2, these sum to 15, which can't be done. So this can't be a 1, 2, 3, 4. Because if this is a 2, these would have to sum to 15. 8 can't go with 7, 6 can't go with 9, 4 can't go with 11. So this can't be a 2. So this is 5, 6, 7, 8, or 9. Can I restrict that any further? Two in this row is in one of those two? So 2 is in one of those two. 2 is in one of those three and one of those three. That not being able to be a 2, does that do anything? If this is 2, 9, these would have to sum to 8. That's easy. 2, 8, these would have to sum to 9. Sorry, if this is 2, 9, these would have to sum to 8. That's easy. 2, 8, these would have to sum to 9. I can't do 2, 7. I can't do 4, 5. I can't. 5, 4 would work. 2, 7, these would have to sum to 10. That's easy. 2, 6, these would have to sum to 11. That's easy. So I'm very confused here. Well, hang on. I've got 1, 2, 3, 4 has lots of places. 5, 6, 7, 8, 9. I'm very lost. So if this is 3, 8, 2, these are 10. These would have to sum to 9. Which could be 7, 2. Or 5, 4. If this is 3, 4, 6, then I must have missed some Sudoku somewhere. I'm looking. Oh, I have missed some Sudoku somewhere. That sums to 5. That sums to 5. There's a 13, right? So 5 plus what gets to 13? That's an 8. That takes 8, 2 out of here. That's the 2. That's not a 2. This is 4, 6. I can take 6 out of there, 6 out of there, 4 and 6 out of there. 4, 6 takes 4 and 6 out of there. That can't be a 2. So in this row, that is the 2, taking 2 out of there. 5 is in one of those two. This is 5, 7, or 9. Which means 6 is in one of those two. Right, now let's look at this. Well, that's a 2. Let's just start with that. One, 2, 3, 4. There's a 6 right here. This is 5, 7, 9. There's no 6 here, and these had to sum to 13. So there's no 7 there. 8 goes with 5, 4 goes with 9. 4 has to be in one of those two. Okay, let's look at this. If this is a 4, these sum to 6, these have to sum to 13. It's easy to do. If this is a 6, these sum to 8, and these have to sum to 11, which is also easy to do. Okay. Four, 5, 7, 9 up here. So 5 is in one of those two. Wow. Hang on. 6 in this row. Can't go in any of those. Can't go there. Can't go in either of those two. 6 is in one of those two, which means that's not a 6. This is only a 4 or a 5. That's got to restrict that. Because 2, the maximum these can be is 11. So the maximum this can sum to is, well, the minimum these can be is 10, which allows that to be 9. But the maximum these can be is 11, with 5, 6, 2, 13, which doesn't allow that to be a 5 anymore. Which isn't quite cutting it, is it? So if this is a 7, these have to sum to 12. I can make those sum to 10, 6, 4. 6, 4, 8, 5, 4, 4, 4. That all fine. That was if this is 7. If this is 8, these have to sum to 9. 5, 4. 6, 6. 8, 4. Seems okay. And if this is a 9, these have to sum to, these would both be 4. 4. This would be a 3, 4 pair, and that seems okay. So is it this now? Yeah, this can't be 9, 4. Because 4 is up here. It also can't be 7, 6. This is 5, 8. So there's no 8 here. This is 7, 9. This is 5, 8. So this is 4, 5, 8. So there's no 5 there. 5 is in one of those two. That's a 7, 9. And that's a 7, 9. So this is now a 7, 9 pair. Because I can't put 7, 9 in either of those or in any of those. That's a 7, 9 pair. So that's a 7, 9 pair. So is it 7, 9 in this box, which can't go in any of those? I don't see it. One, two, three, four, five, six. So these are from 4, 5, 6, and 8. There's no 4 here, there's no 6 here. 5 is in one of those. 3 in this row is in one of those two. All I know is 3 is in one of those. This is 4, 9. 9, 9, 9. Is it colouring these 7 9s in some way? Like, if this is one version of 7 9, this is the other. So this would be yellow, this would be blue. This would be yellow, this would be blue. This is blue. How do I feed that into the others? Like getting it into these ones. If this is a 9, I'll bet you it's really obvious and I am just blind. Well, those cells and those cells. If this is a 9, remember these sum to 1938. If this is a 9, we've got 11, 17. So these would have to sum to 21. So they're 21 or 23. If it's a 7, they have to sum to 23. Or they're 21. What's the maximum they could sum to? 8, 5. Well, we know... No, that doesn't work, because we know what they sum to. These sum to 13. If this is 8, 5... That's yellow, blue, yellow. But if this is 4, 9, I don't know what that's telling us at all. If this is 4, 9, this is a 7. So this is 5, 7. 5 and 7 is... If this is 4, 9, this is 5, 7, because it becomes that digit. If this is 4, 9, this is 5, 7, which is 12, 14, and that would need to be a 5, and it can't be. This is an 8. This is a 6. This is a 5. This is a 4. Wait, what? Yeah, hang on. If this is 5, 9... So if this is 4, 9, this is 5, 7. 5, 7 is 12, plus 2 is 14, and that would need to be a 5, and that doesn't work. 4, 9, 7, 5 doesn't work. This is an 8. This is a 6. This is a 5. This is a 4. 8 means this is 5. This is not 5. These sum to 6. So these have to sum to 13, which is either direction. This is now yellow. So this is blue. This is yellow. This is 8. This is 5. So we know what these two are. 1, 2, 3, 4, 5, 6, and 8. What did I just do? These are 3, 7, 9. Oh, the 8 makes that the 5, which makes that the 8. The 5 makes that the 8, which makes that the 5. The 8 takes 8 out of those. The 4 makes that the 6 and that the 4. I'm still terrified I've done something terribly wrong here. These have to sum to 13. I'm hoping I haven't made a terrible blunder. Four, 6, 7, 9. Because these have to sum to 13. 6, 7. Or 4, 9. Where's 8 in this row? This 6, 8 means I can't put 8 in any of those. 8 has to be in there. This is an 8. So this is a 3, which means this isn't a 3. This is the 3. This is now only a 4 or a 5. This is 4, 5, or 6, and it's not a 5. 6 is in one of those two, making that the 8 and that the 6, meaning this isn't the 8, that's the 8. Still not allowing me to colour these, or these. These are 4, 5, 7, 9. But what is going on? This is yellow. So this is blue, this is yellow, this is blue, this is yellow, this is blue, this is yellow. So do I now need to colour? If this is 7, this is 6. But there's nothing else to interrupt that. Is there? I've got no other math playing with those numbers. The only math left to resolve is this. Oh, the 4 makes that the 6, which makes that the 5, and that the 4, which makes that the 6, that the 4, that the 6. That's what I'd missed. So these are 12, so that's the 7. So blue is 7, yellow is 9. Wow. Didn't do great on that, did I? The 4 looks across, making that the 5. I can take 5 out of there. I can also take 9 out of there. The 7 looks across, making that the 4, which makes that the 7, and that is the solution to the puzzle. That had some chops. That had some real chops to it. I'm sure there was something I missed that resolved this a lot smoother. Like this stuff, I'm sure there was something that resolved that a lot smoother. But that was a tricky puzzle. At least it was to me. 1319, 1319, I got absolutely hammered by that. But I had a lot of fun solving it because I always have fun solving Riffclown puzzles. I learned something. I have no idea what I missed along here. This stuff was tricky. I definitely missed the stuff over here resolving this. Like this 1-4, I spent probably, 10 minutes missing this 8, which would have resolved this, which gave me more. But there was still a lot to do here. And figuring out these as a sum, I'm not sure if that was needed, colouring the 7 9s. There was definitely a lot of tricks needed to pull this one together. But I really enjoyed it. Thanks, Riffclown, for the puzzle. Yeah, really, as always, lots of fun. Thanks everyone for watching, and as always, good luck with your solving.